Hello classmates, welcome to our classroom. In this class, we will learn knowledge related to the composition and working principle of steering systems. In daily driving, the steering system of a car is a key component of vehicle handling. Whether shuttling through busy urban streets, still galloping on the wide road, we all need to rely on reliable steering systems to ensure safe and stable driving. It is responsible for controlling the direction of vehicle travel, ensure that the driver can drive according to the intention. Our main learning objectives for this course are three, namely 1. Understand the basic concepts of automotive steering systems. 2. Master the composition of the steering system. 3. Understand the working principle of the steering system. We will learn through the following three parts. 1. Basic concepts of steering systems. Automotive steering system refers to a collection of mechanisms and devices used to control the direction of vehicle travel. It is an indispensable system in vehicle operation. Its main purpose is to make the vehicle change or maintain its driving direction according to the driver's intention. It not only affects the comfort and convenience of driving, more directly related to driving safety and stability. Therefore, for every driver, automotive technician, and vehicle engineer, understanding the basic concepts and importance of automotive steering systems is crucial. Two components of the steering system. The steering system of new energy vehicles mainly consists of the following key components. 1. Electric power steering. 1 motor, as the power source of EPS, output appropriate assist torque according to the instructions of the electronic control unit. Brushless permanent magnet DC motors are commonly used, having low speed and high torque. Small fluctuations, small moment of inertia, small size, lightweight, high reliability, easy to control, and other characteristics. To reducer, connected to the motor, the effect of increasing takeoff and landing speed and torque. Worm gear or planetary gear mechanisms are commonly used. Ensure that the power output from the motor can be efficiently transmitted to the steering mechanism. 3. Steering. The steering gear is the core component of the steering system. It converts the steering force input by the driver through the steering wheel into appropriate output torque, transferred to the steering transmission mechanism. Common types of steering gears include gear rod type, worm crank finger pin type, and circular ball style, etc. 2. Steering sensors. 1. Torque sensor, integrated inside the steering column, measure the torque and direction exerted by the driver on the steering wheel and the size and direction of the steering wheel angle. This is one of the sources of control signals for EPS. 2. Vehicle speed sensor, used to collect vehicle speed information, input the torque sensor signal together with the electronic control unit in order to achieve more precise control. 3. Electronic control unit, as the brain of the steering system. It could, based on signals from torque sensor and vehicle speed sensor, after comprehensive logical analysis and calculation, send instructions to control the motor action. Meanwhile, ECU also has safety protection and self-diagnostic functions, ensure stable operation of the steering system. For other auxiliary component mechanisms, 1. Steering maneuvering mechanism. This is a component directly operated by the driver, mainly including steering wheel, steering column, etc. The driver inputs steering commands by turning the steering wheel. To steering transmission mechanism. The steering transmission mechanism transfers the torque output from the steering gear to the steering wheels, deflected according to the driver's intention, thus achieving the turning of the vehicle. The transmission mechanism includes steering arm, steering rod, steering arm, turning trapezoidal arm, and components such as steering tie rods. 3. How the steering system works. The working principle of the steering system for new energy vehicles can be summarized as follows. 1. Signal acquisition. When the driver turns the steering wheel, the torque sensor starts working, measure and collect torque and rotation direction signals on the steering shaft. Meanwhile, the speed sensor also collects real-time speed information. to signaling and processing collected signals, including torque signal, direction of rotation signal, and vehicle speed signal, transferred to the electronic control unit. The microcomputer in the ECU uses these signals after comprehensive logical analysis and calculation, determine the rotation direction of the assist motor and the magnitude of the assist current. 3. Boost output. According to the instructions of the ECU, the motor in the electric power steering mechanism starts working. After the motor reduces the speed and increases the torque through the reducer, transferred to mechanisms such as steering gear or steering rack. With the assistance of the motor, drivers can turn the steering wheel more easily. For steering realization, under the assistance of the motor, the steering force is transmitted to the wheels through the steering mechanism. The wheels deflect according to the direction and magnitude of the steering force, thus achieving the turning action of the vehicle. Through this course, we have learned the composition and working principle of automotive steering system. I also deeply appreciate the importance of the steering system for driving safety and comfort. In daily life, we should always pay attention to the status of the vehicle steering system, discover and solve problems in a timely manner, ensure safe and stable driving. The above is all the content of our lesson. Goodbye, classmates.